Welcome to another video for physical science. In this video, we're going to be discussing the solar system. This is an introductory video to the solar system. We're going to kind of broaden the scope and just get a historical perspective and see what led up to the modern ideas of how we understand the solar system today. So as you can see here on my first page, we have some very famous scientists of antiquity that, well, maybe Einstein isn't ancient, but these guys helped to develop the ideas that make up our understanding of the solar system today. So, like I said, let's take a historical perspective. So, throughout history, man has used the stars for direction and for time and for seasons. For example, the ancient Mayan culture had observatories. And if you look at this observatory, it doesn't look that different from the modern ones that we have today. And they followed the sky, they followed the stars, and they created the most accurate calendar that we have today, the ancient calendar anyways. And they had a whole religious system based off of the stars, much like many of the other ancient cultures. But either way, they developed some very sophisticated science by taking very careful measurements and observing how the stars move throughout the sky and throughout the years. Stonehenge is another example of a very interesting, we don't really know for sure what Stonehenge is. Was it a religious temple of some sort, or was it purely scientific? And the suspicion is that it was probably a mixture of the two. But either way, Stonehenge is pretty interesting in how they developed it and how they built it, because they have something what's called the heel stone. You can kind of see it at the bottom there, the heel stone. And every year, and the first day of summer, the sun will come up on the heel stone, right on it. Now, it's maybe like a 1 degree or so off, but I guess depending on where you're standing at the center of of Stonehenge, you can see the sun directly over that particular stone. And there's a huge festival and everything every summer to kind of kick off the summer by watching the sunrise over that stone. But there's some new investigations that they've done over Stonehenge, and those massive pillars that you see, they're called trilithons. If they took very careful studies of these, and on the reverse side of the Stonehenge, you could see the sunset. The sunset during the winter would go right in between those trilithons, and it would create this really nice passage of light that would go throughout the whole Stonehenge. And again, now was this religious, the Druids, or was this purely scientific? And again, we don't know for sure. But what we do know is that they took very careful measurements and they developed the Stonehenge around the movement of the sun and actually the moon as well. Because some of the stones that were positioned around Stonehenge actually follow the paths of the moon. And they actually developed this idea that we understand clearly today, that every 19 years or so, the moon kind of resets its position in the solar system around the Earth. And Stonehenge shows that. So, it was ancient, about 4,000 or 5,000 years ago or so, but very sophisticated nonetheless. And another very sophisticated ancient building is the Egyptian pyramids. Now, the Egyptian pyramids, again, these were primarily used to bury the pharaohs. Now, there's a suspicion that they were used for, they had other purposes as well, but for sure we know that the pharaohs were buried there, and the positioning of the opening for the pharaoh and the pharaoh's tomb lit up or was opened directly into the stars at an upward trajectory. And the idea is that they wanted to create a clear path for the pharaohs to go back up into the stars, because as you know, the Egyptians also had a religious system that was very much dependent on the solar system. Like the sun, for example, was their main god, Ra. So if you were a pharaoh, that's where you got to go. You got to go up into the heavens. Okay, and the positioning of the pyramids also is a very exact positioning and where they have met. So pretty interesting stuff. And so, continuing on with our ancient cultures, the Romans and the Greeks actually named these planets. So they knew about 5 planets, and they could see them with. These are the ones that you could see with the unaided eye. You have Mercury, Venus, Mars, Jupiter, and Saturn. And the Romans actually gave names to these. Mars was the god of war. Saturn was the god of agriculture. Venus was the god of love. Neptune, which we don't have here actually, but Neptune was the god of the sea. Jupiter was the king of the gods, and then you have Pluto, who was the god of the underworld. I don't have Pluto on here because technically Pluto is no longer a planet, that dwarf planet. It's considered more of a kind of like a satellite, a moon, if you will, or like just a random rock that's floating around our solar system. So the ancient idea that this idea that the Earth was the center of the universe and everything else revolved around the Earth is called the geocentric model. And this idea, again, like I mentioned, was the thought because people would see the sun rise, they would see it set, and they just kept noticing that pattern, and they just assumed that everything revolved around the Earth. And then, of course, we have something called the heliocentric model, which means heliocentric means the sun is the center and everything revolves around the sun. And we know this to be the accurate depiction of it. So the geocentric model was pushed by the Egyptian astronomer Ptolemy. Ptolemy was very much into Babylonian astronomy and astrology, actually. He helped to push that a lot. And his ideas were adopted by the Catholic Church along with Aristotle. And I have a video actually where I discuss this in greater detail, and I'll have a link up here so you can so you can go and watch it as well, where I go more in depth with Ptolemy and Aristotle and the effects that they had on science and the issues that they gave other scientists. So here's a drawing back in the 16th century of the geocentric model where the Earth is in the middle and then all the other planets' orbits are drawn around it. And then here's another drawing with the heliocentric model where the sun is takes front and center, and then everything else, all the other orbits are surrounding the sun. So Ptolemy and Aristotle were the main proponents to this, and they caused a lot of issues because, like I mentioned, the Catholic Church adopted their ideas and they considered them gospel. In fact, if you look at Aristotle's ideas, a lot of his stuff was adopted, and people had a very hard time getting past what these guys did. And so along comes Nicholas Copernicus and Galileo. Now there were others that were before these guys also, actually, but I'm just going to highlight these two. Actually, Johannes Kepler also, but Nicholas Copernicus and Galileo, who were at odds with the Roman Church because their studies and their research and the research of other scientists showed that, in fact, the heliocentric model was the more accurate model. But like I said, in the video that I highlighted before, when I was talking about Ptolemy, I discuss in greater detail what those issues were. Now, planetary orbits. Planetary orbits are traditionally thought to be circular. So things that are going around the sun, the thought is that they go in a perfectly circular pattern. But in fact, they don't. And again, this was research done by a German scientist, Johannes Kepler. He also had issues with the church too because of his research. The Catholic Church said that the Earth goes around the sun in the sun goes around the Earth, or everything orbits everything else in a perfectly circular pattern. And Johannes Kepler came along and said, well, not actually. Okay, so he looked at the planetary orbits and he noticed something a little different. Okay, so here you have the Earth orbiting around the sun, and Johannes Kepler in his research stated that, in fact, the Earth's orbit around the sun is more elliptical. Okay, it's not a perfect circle, it's more elliptical, it's elongated. So how do planets maintain their orbit? How is it that a planet is able to stay in its path year after year? Well, thanks to another scientist, Isaac Newton, we understand why planets stay in orbit. Because, well, if you look at Newton's first law, an object in motion continues to move in a straight line at a constant speed unless acted upon by a force. So Newton's first law, as it states, if we look at planets and we apply Newton's law by the letter, a planet, like Jupiter, for example, as it goes by the sun, unless it is acted upon by another force, should stay in a single straight line shooting right past the sun. But in fact, it doesn't. Jupiter actually revolves around the sun, and it revolves around it in a elliptical shape. So it's almost like, pretend like you have Jupiter tethered to the sun by a rope, and as you're swinging it, okay, there's a force that's being applied. Now, if not for that rope, Jupiter would just continue on in a straight line, but it doesn't. It maintains a particular elliptical pattern around the sun. And that rope is what we consider gravity. So the sun's gravity is actually maintaining Jupiter and every other planet in the solar system in the same elliptical orbit. So something is going on here. There's a force that is being acted upon these planets. Let me take a step back real quick. There's a force that's acting on these planets that helps them maintain that elliptical orbit around the sun. And that force we call gravity. Okay, and again, thanks to Newton, we understand that. So when you combine the two ideas that Newton came up with, his first law of motion, that an object in motion will remain in motion unless acted upon by a force, you add that, you couple that with the force of gravity, then you understand why these orbiting bodies remain in their constant orbital elliptical orbit around the sun. Now, another way to look at this is Einstein, his theory of relativity. And what he stated is that if you think of space as kind of like a blanket, just like a blanket that's being laid out. And the sun, when it's put on that blanket, it creates an indentation. And that indentation is where planets, or that indentation is what we would consider the gravitational pull. But what Einstein was stating is that maybe it's not necessarily gravity per se, but it's the way that the sun is bending space around it. So the sun is taking up this space in space, and it's bending space, and it's creating this divot, if you will, a warped space around it, and the planets are getting caught up in that warped space, and that's what's causing them to stay in their orbit. It's actually a pretty cool idea when you think about it. So if you think about it this way, well, the sun, or the Earth itself, also takes up space. It also has a mass, which also makes an indentation in the space that it takes up. So then you have the moon that's orbiting around the sun, and so that's what causes the moon to orbit around the sun. And we create this very sophisticated system where you can actually have life on Earth. Because as we'll discuss in future videos, the moon plays a huge role in the balance that Earth strikes to have life. It's actually a very intricate system when you look at it. It's been divinely created, if you will. So if we're looking at the Earth and the moon, the Earth, like I said, creates its own indentation in space, and the moon orbits around that. Okay, well, that does it for this video. Well, actually, this is how this all plays out with the solar system and how everything is orbiting around the sun itself. All right, so we have Newton's first law working together with gravity, keeping everything in its perfect position around the sun. Well, that does it for this video, the solar system. This is an introductory video. There will be more as we continue on in this lesson. Good luck in your study.